Okay, so let's do one example about the Clapeyron equation. It's not an example really, it's a question basically. So this is the question we have about the Clapeyron equation. So the question reads, the Clapeyron equation, which is also given here, enables us to determine the enthalpy of vaporization, which is HFG, at a given temperature. So we already know that. This is the Clapeyron equation. Now the question is asking whether this equation involves any approximation or this is an exact equation. So the answer is the Clapeyron equation is in fact an exact equation. There is no approximation considered to come up with this equation. The Clapeyron equation is an exact equation. So there is no approximation done for the Clapeyron equation. The second part of the question is asking for the Clapeyron-Clausius equation. So just to review, the Clapeyron-Clausius equation says natural log of P2 over P1 is approximately equal to HFG over R 1 over T1 minus 1 over T2. Okay, so this equation, which is, by the way, this is Clapeyron-Clausius, this is not an exact equation. This is an approximated equation. The reason that this is an approximated equation here is because of the fact that we approximated VFG with VG. So let me just write this down. The Clapeyron-Clausius equation is an approximated equation. This is because in order to obtain this equation, VFG was approximated with VG at low pressures. So we did one video about this Clapeyron-Clausius equation, and in order to derive this equation, we did this approximation. So basically, we started with the famous Clapeyron equation, and we approximated VFG simply with VG because we were discussing about low pressures. So finally, that's pretty much about this question. So the question was asking about two separate equations. The first one is the Clapeyron equation. This is an exact equation, but the Clapeyron-Clausius equation, which is this one, that is an approximated equation.